Okay, good morning. Yeah, so once again, it's another fine morning, and today, Mr. Dan has something to present unto you, and I believe that you are ready to grasp that content that we are coming with today. Now, today, under chemistry, we want to learn something different, and we want to learn units under the SCI. And in this unit, we are going to discuss on the amino acids, protein, peptides, and then the carbohydrates. And the first that we're going to tackle today is the carbohydrates. Okay, carbohydrates. Now, when you hear the term carbohydrates, you know what you think in your mind is food. Yeah, which is right, because carbohydrates, you get that it is always a food group. Okay, yeah. When you're speaking about the three food groups, you always have the carbohydrates as among them. And in chemistry, we also get to learn about the carbohydrates. Okay, because I believe you learned that in biology. Okay, we're going to learn of the building block, or what makes up the carbohydrates. What does carbohydrate constitute of? That is what we're going to discuss here in chemistry. We have a formula for the carbohydrates. Okay, and the formula of carbohydrates, get that it is always C, and you can open our bracket there. Okay, H2O, close bracket, then we have the N. So from this formula, we get the proportionality of the carbohydrates. Okay, in how many proportions do we have the carbon? In how many proportions do we have the hydrogen? And in how many proportions do we have the oxygen? Okay, and from that I believe you can see that the proportionality of carbon and the oxygen will be 1:1. Okay, but for the hydrogen it is double. Okay, it is like in this manner of 1:2:1. Okay, so that is the proportionality of the carbohydrate. Okay, yeah, so this one is the formula for carbohydrates. And from that, we can derive, or we can know the constituents that makes up the carbohydrate. We get that we have the carbon, okay? We have the carbon, we have the hydrogen, and oxygen. So these are the constituents that make up the carbohydrate. So in simple terms, you can say that carbohydrates, they consist of carbon, okay, hydrogen, and oxygen, okay, and they are either polyhydroxide, aldehydes, or ketone. Polyhydroxide, aldehyde, or ketone. We're getting polyhydroxy, we're getting aldehyde, and we're getting ketone. Okay, because we've gotten that carbohydrates consist of carbon, hydrogen, oxygen, okay, and they are polyhydroxyaldehydes or ketones. Okay, so they consist of this atom, carbon, hydrogen, and oxygen, and they are either polyhydroxyaldehyde or ketone. So these ones are the ones that tell you what carbohydrate constitutes. It consists of carbon, hydrogen, and oxygen. Okay, and they must either be an aldehyde or a ketone. And remember, they have to be polyhydroxy. Okay, polyhydroxy. When we refer to polyhydroxy, it means it's having several hydroxyl groups. Okay, then we get that the aldehyde is also a functional group. Okay, a ketone is also a functional group. So these two are functional groups. Okay, and we want to understand that how does an aldehyde look like? Okay, and how does the ketone look like? How does the aldehyde look like? And how does a ketone look like? Okay. Through that, for us to get an easy understanding of how an aldehyde and a ketone look like, we're going to draw the structure of two monosaccharides. Okay. We need to draw the structure of two monosaccharides. And from that, I believe it will be easier for you that is over there watching to know the difference between an aldehyde and a ketone. And now, we're going to draw the structure of a glucose and the structure of a fructose. Okay, the structure of a glucose and the structure of a fructose. Okay, so the first thing that you should know that for a glucose and fructose, they're having how many number of carbon atoms? Okay, because the number of carbon atoms present are always 6. Okay, so we're going to use the picture projection in drawing the structure. Okay, so when using the picture projection, we already know that carbon, that the number of carbon present is 6. Okay, so we draw the carbon present. So 1, okay, 2, remember the picture projection, 3, 4, 5, and even 6. Okay, 6. And now, for an aldehyde, remember a glucose is an aldehyde, it will have a double bond here to an oxygen, and over here we're having a hydrogen atom. Okay. The second group is that the carbons are also bonded to each other. Okay. So the second group over here, we will be having the OH, hydroxyl group. Okay. Here we're having the hydrogen. Over here we'll be having the hydrogen, and on this side we'll be having the OH. Okay. Over here we'll be having the OH, and over here we're having the hydrogen. Over here we have the OH, over here we have the hydrogen, and over here we're having CH2OH. Okay. Now this one is the feature projection of the glucose. Okay. That is how the glucose look like. Okay. That is the feature projection for the glucose. And now for a fructose, you get that this is how it looks like. You have the carbons, first they are 6. Okay. So you have the 1, 2, 3, 4, 5, 6. Okay, 6 carbon atoms. Okay, and they are bonded together. They are bonded together. Okay, and we have that. The first one ever we are having CH2OH. Okay, then we have a double bond to oxygen atom. Okay, and over here we are having the H. Over here we have the OH. We have the OH. Then over here we have the OH, H, OH. You have the H, and you have the CH2H. Yeah. Now, this one is the feature projection for glucose. This one is the feature projection for fructose. Okay. And remember that the reason being as to why I drew them was for us to get an easy and faster understanding of how does an aldehyde group look like and how does a ketone group look like. Okay. So, when we check on this one, we have something over here. I'll check on that functional group. Okay? Let's see, we have one over here. Okay. I believe that when we check on this one, we have carbon. Okay? The first carbon is having a double bond to an oxygen atom. Okay? And also an hydrogen. Then the carbon is attached to another carbon. When we get on this other one, okay, we have that the carbon, the first one is an alcohol, okay? Then it is attached to a carbon, and now the second carbon is the one now attached to a double bond of an oxygen. I believe you can see the variation, okay? You can see the variation. Over here, you have the O is attached to the second carbon, okay? But over here, we are having the oxygen atom attached to the first carbon. So that should enable you to differentiate between an aldehyde group and a ketone. Okay. For an aldehyde group, the first the oxygen atom is attached to the first carbon, running for an aldehyde group. But now for a ketone, you get that the oxygen atom is attached to the second carbon atom. Okay. Yeah, so this one will enable you to differentiate between an aldehyde and a ketone. So for an aldehyde, this is how it looks like. And for a ketone, this is how it looks like. Okay. So for glucose, you can say it is an polyhydroxy aldehyde. Okay. It is a polyhydroxy aldehyde. For glucose, it is a polyhydroxy aldehyde. But for fructose, it is a polyhydroxy ketones. Okay. So for glucose, it is a polyhydroxy aldehyde because of several hydroxyl that are present. Okay. But for fructose, it is a polyhydroxy ketone because of the functional group. Okay. So remember to mark on the functional group. It will enable you to differentiate between an aldehyde and a ketone. Okay. For an aldehyde, you get that the carbon atom, the oxygen is attached to the first carbon atom. But for a ketone group, you get that the oxygen atom is attached to the second carbon atom. And that is how it looks like. Okay. Yeah, so I believe that you've been able to differentiate between an aldehyde and a ketone. Okay. And the reason as to why we said that carbohydrates, they are polyhydroxy because of several hydroxide ions. Okay. So I believe that you've understood to differentiate between an aldehyde and a ketone. Okay. And now I'm just going to give you we're going to work on some examples just to confirm that does this one fit to being a carbohydrate? Okay, yeah, just that simple. We're going to check on some examples just to confirm that does this one fit to be a carbohydrate? Okay, Yeah, so I'm going to do some structures and we're going to check on them and just distinguish if it is a carbohydrate or it is not. So let's check on that next part very fast. We're going to check on some examples, okay, and check if does this compound really fit becoming a carbohydrate. And we're going to try to give reasons why that maybe if it fits or it doesn't fit. Okay. And now the part that I'm going to draw you is this. Let's say one that's having 3 carbons. Okay. And over here you have the OH. That's that way. You have the OH. And you have the H. Okay. And now over here you have the H2OH. So we have that compound. So let's say this one is A. So that is A. Let's check on B. So B, let's say we have CH2OH, okay? Attached to one. Another carbon over here. Let's say there is another carbon over here. Over here, let's say we have OH. And over here we have the H. And over here now we are having CH2OH. Okay, I believe you can see. Yeah, so that one is B. So for C, let's say we are having like CH2OH. Okay, then you have the carbon over here. The double bond for O. And you have CH2OH. CH2OH. Then you have the CH. So let's say that we're having these ones over here. Then you are asked that which ones are carbohydrates. So if you are given such and you are asked that which ones are carbohydrates. Okay. So remember that we said when you are confirming either of them fits to the carbohydrate, you have to check on 3 things. Okay. You have to check number 1 on the polyhydroxy. Okay, and it has to be either an aldehyde or a ketone. So these 3 will enable us to distinguish if they make up a carbohydrate or do not. So let's check on the first one. Does it fit being called a carbohydrate? And if it does, what makes it fit as a carbohydrate? So you get that for choice A, so we have the aldehyde functional group, and we also have the hydroxy over here, also we have hydroxy over here. So automatically, they already fit being a carbohydrate. Okay, why? Because the molecule contains an aldehyde functional group, okay, with OH groups on the other 2 carbon atoms. It contains OH group on the other 2 carbon atoms, which is this one and this one, okay, and it contains an aldehyde group. So A fits being an carbohydrate. So for A, it is a carbohydrate. And this is asked why? Because it is having an aldehyde group, okay? An aldehyde group and the OH group on the remaining 2 carbon atoms. Therefore, it fits being a carbohydrate. So I believe you've seen that. So A fits being a carbohydrate. Let's check on our next option, which is B. So B, does it fit being a carbohydrate? Does it fit being a carbohydrate? Check on B. Check on B. Does it fit being a carbohydrate? Then check on B. Let's first begin. Do we have the hydroxy? We have the hydroxy over here, we have the hydroxy over here, and the hydroxy over there. So for the polyhydroxy, it fits that, okay? But let's check on the functional group. Does it have an aldehyde or does it have a ketone? Let's check on this. Is there an aldehyde? Do you have a ketone? It doesn't have. Okay, it doesn't have. So we get that B does not fit to be a carbohydrate. So B isn't a carbohydrate. And if you are asked why, it is because it doesn't have, okay, it doesn't have It doesn't have aldehyde or ketone functional group. In that way, we disqualified the choice B. Choice B does not fit being a carbohydrate. So let's check on choice C. So here is C. Okay, here is our C. So does C fit being a carbohydrate? The choice C fits being a carbohydrate. When you check on that choice, you get that we have the hydroxyl functional group, okay, on the two carbon atoms, this one and this one, okay. And you get that on the second carbon atom, we are having an oxygen, okay. There's a double bond to oxygen. Now this one is a ketone functional group. It fits being a ketone functional group, okay. So this one fits being a ketone functional group. Those are the hydroxy here and the hydroxy there. So C fits being a carbohydrate. So C is a carbohydrate. And if you ask why, because it is having the ketone functional group and the polyhydroxy group. And therefore you get that C fits being a carbohydrate. C fits being a carbohydrate. And let's check on the last option that we had, option D. So for option D, you get that for D, we have the ketone functional group here. We have the ketone functional group. And you get that when, for the functional group, whether it's a ketone or an aldehyde, you get that it fits being a ketone. But how about the polyhydroxy? Because we only have the hydroxy on the first carbon. But the first carbon, there is no hydroxy. So it mutates on the polyhydroxy. Therefore, D doesn't fit being a carbohydrate. So D, it isn't a carbohydrate. And if you are asked why it doesn't mark the polyhydroxy, it doesn't fit on the polyhydroxy, though it is a ketone functional group. So that way you can be able to distinguish between whether a compound fits being a carbohydrate or it doesn't fit. Okay? Yeah, so for this you get that A was a carbohydrate, okay? B, it wasn't, C was a carbohydrate, and D wasn't a carbohydrate. And we have also analyzed on the reason being, okay, and I've also just given you a review of how you can be able to distinguish between them. You check on the polyhydroxy, check on the aldehyde, and ketone functional group. So these three will enable you to know whether one fits being a carbohydrate or it doesn't. So I believe so far you've learned something, right? Yeah, I believe you grasped something, and now you are able to distinguish or to know whether something fits being a carbohydrate, okay, and whether it doesn't fit also being a carbohydrate, okay. Yeah, and you also know that plants, they always do make their carbohydrates, okay, through the process of photosynthesis, okay. So for plants, in the process of photosynthesis, they make the carbohydrates, okay. And once they are made, they are converted into starch, okay, into starch or cellulose. You get that the cellulose is the cell component of the plant, okay. You get that especially when the wall, the cellulose of the plant is made of cellulose, okay. But now the starch, it can be stored, okay, later on to provide the plant, it provides the plant with energy, okay. That is for starch. But the cellulose, it makes up the cell component of the plant, okay. Yeah. And I get that human beings can synthesize our own carbohydrates, and therefore for human beings to depend on the plant. That is where we get the carbohydrates from. Okay, that is where we get the carbohydrates from. And later on we'll also get to learn on the classes of the monosaccharides. Okay, you'll get to know that or the basic component of the carbohydrate is the monosaccharide. Okay, the monosaccharides. Okay, so these monosaccharides, they are the basic carbohydrates that we have, okay, and these monosaccharides, they have the tendency, okay, of that they can combine with one another to form an even bigger, okay, or even a more advanced carbohydrate, okay. Get that now from the monosaccharide, we can get a disaccharide, okay. From the disaccharide, it's formed when two monosaccharides come together and combine, okay, and they can give you a disaccharide. But now when they come three and combine, they give you a trisaccharide, okay. And now when you get that when they combine several of the monosaccharides, Now they will give the polysaccharide. Okay. Yeah, so all those we'll get to know them, and we'll get to know how they form. Okay. We'll get that the process of breakdown, whereby you get that once even a polysaccharide has been formed, or even a trisaccharide, or even a disaccharide, they can be broken down to get the basic one, which is the monosaccharide. And the process of gaining them is known as through hydrolysis. Okay. When you hydrolyze the polysaccharide, you'll get the monosaccharide. Okay. Yeah. So I think we'll leave at that point. But this class was majorly for you just to know how to distinguish or how to know whether something fits in a carbohydrate or it doesn't. Okay. Yeah, of which I believe that is not. Just to review that, let's mark on these three: polyhydroxy, aldehyde, and ketone. That way you know. Okay. So I believe you learned something. And after that, see in our next class, whereby we learn the classes of monosaccharides. But it's done. So see you next time, and don't be late. Bye.